Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. Today, we would like to present about stationary points. But firstly, we would like to introduce ourselves. My name is Muhammad AFIQ bin Rahim. My registration number is 01DE21F1050.
And
And
my
next, I will
name
pass it to Ahmad Faidi.
and my name is Ahmad Faidi bin Ahmad KHUSHAIRI from class DE2B, and my registration number is 01DEE21F1038. And next I will pass to Faiz Shauki.
Okay, my name is Shauki bin MARZUKI and my registration number is 01DE21F1037.
Okay, for the first, I will talk about the differentiation. Okay, differentiation is a technique which can be used for analyzing the way in which function change in particular. It measures how rapidly a function is changing at any point in engineering. The function may, for example, represent the magnetic field strength of a motor, the voltage across a capacitor, the temperature of chemical mix, and it is often important to know how quickly this quantity change. And that was the formula of differentiation. Next, I will pass it to Ahmad Fadi to talk about example of application of differentiation of real life.
Okay, I will continue from AFIQ. So I will talk about example of application of differentiation of real life. So in our discussion, we use radar guns. Firstly, keeping with the automobile theme from the previous slide, all police officers who use radar guns are actually taking advantage of the easy use of derivative. When a radar gun is pointed and fired at your car on the highway, the gun is able to determine the time and distance at which the radar was able to hit a certain section of your vehicle. With the use of derivative, it is able to calculate the speed at which the car was going and also report the distance that the car was from the radar gun. Next, I will talk about our question that given for this presentation. Firstly, use differentiation. In this question A, which is the graph of a curve with y equal to negative x powered by 3 plus 12 x powered by 2 negative minus 336 x. So the formula we use is dy per dx equal to negative d per dx multiple by x power by 2 plus d per dx multiple by 12x power by 2 plus d per dx and multiple by negative 36x. So in this formula, we will derive it. So the answer after we derive it, we'll get the answer is negative 3x power by 2 plus 24x and minus 36. So after we derive it, we get this answer, and after the answer we need to factorize it. So the answer after we factorize it is negative 3 multiplied by x minus 2 and multiplied by x negative x minus 6. So next one is find coordinates. So for the B, the question is to find the stationary points. So the formula is dy per dx equal to 0, and 0 equal to negative 3 multiplied by x negative 2 and multiple x negative 6. So the answer will get negative 3 x negative 2 equal to 0 and x equal to 2. For the other one is x negative 6 equal to 0 and we will get it x equal to 6. When x equal to 2, y equal to negative x power by 3 plus 12 x power by 2 and negative 36x. So we put the x, we put it when x equal to 2, we will get negative 2 power by 3 plus 12 power by 2 12 multiple 2 power by 2 and negative 36 multiple 2. And the answer we will get after calculate it, we will get negative 8 plus 576 minus 72, and we will get the answer is equal negative 32. So when y equal to 6, we will get when x equal to 6, y equal to negative 6 power by 3 plus 12 multiple 6 power by 2 and negative 36 multiple by 6, and we will get the answer for the stationary point is 2, negative 32 and 1 0. So for the question C, they ask how many stationary points. Therefore, stationary points we will get is 2, negative 32 and 1 0. And next I will pass to Faiz Shauki.
Okay, next we go to question D. As we know that if we want to find y-intercept, we need to substitute x with 0. By that, we got y-intercept equal to 0. Okay, for question E, the question asks to determine the nature of any sectionary point based on part C. First of all, I have to do the second derivation, which is d power by 2 y over dx power by 2. Then I got d power by 2 y over dx power by 2 equal to negative 6x plus 24. As we know that I have the sectionary point based on part C, which is the coordinates 2, negative 32 and second coordinate 6 and 0. By that, we can substitute the value of x into the equation. So for x equal to, I got 12, which is the minimum point, and for x equal 6, I got negative 12, which is the maximum point. For the question F, the question asks to sketch the graph of the curve, so we already know the maximum and minimum point and also the y-intercept. By that, we just directly sketch the graph like at the slide. Okay, lastly, for the summary. To summarize the presentation, differentiation is used to determine the sectionary point of the function y equal negative x power by 3 plus 12x power by 2 negative 36x in order to sketch the graph. And after we do the derivation, factorize, and substitute the sectionary point that we get are 2, negative 32, and second coordinate 6, 0. Then we use the second derivation and test to determine the nature of the sectionary point. From that, we got coordinate 2, negative 32, dy over ds equal to 0, and d power by 2 y over dx power by 2 more than 0. At the second coordinate 6, 0, dy over dx equal to 0, and d power by 2 y over dx power by 2 less than 0. Okay, that's it from us. Thank you for listening our presentation.